in Gulf and African countries, currently playing multiple roles like professor, syllabus committee member for various universities, members of board of studies for many academic institutions, advisors in startup, motivational speakers, TV resource persons, etc. With this few introduction, I request our professor, our chief guest, today's chief guest, Professor ELANGOVAN RAJAGOPALAN sir, to continue his lecture. Professor RAJAGOPALAN sir, please. ELANGOVAN sir. ELANGOVAN sir. Sir, unmute yourself, sir. RAJAGOPALAN sir, ELANGOVAN sir. Sir, unmute yourself, sir.
Good evening, everybody. Good evening. So it was a very happy occasion. ரொம்ப சந்தோஷமா இருக்கு. உங்க மாதிரி engineering stalwarts பார்க்கிறதுக்கு. ஏன்னா I am a very ordinary student from Mannagam High School, which walked without chappals to the high school. The age, full high school was raised only in the seashore of Rameswaram. So I get acquaintance with Dr. Abdul Kalam when I was very young. And I was very practical and I was very materialistic. I was a fan of hardcore fan of MGR also at the same time. So once in the high school, they asked me a question, teacher asked me a question, how will you prove Earth is round? Everybody was telling a standard honor, there is a, if you go to the seashore and see the ship coming, you can see the smoke. After that, you can see the body deck, like that everybody was explaining. Then I told here, no, if we go by rocket upstairs, we can see the, if we look below, we can see the Earth is round. The teacher appreciated and okay, definitely you will, one day you will launch rocket. It has come true. And he asked me how you answered. Sir, yesterday I saw an MGR movie in that he was going to abroad. There was a movie called Kalayarsi. In which MGR is chasing the heroine up to the next world by going by UFO and everything. So I enjoyed the movie. Then only I saw that rockets and everything was very interesting to me. Actually, the movie has a very strong background. It is written by the director is from Oxford. He studied in Oxford with all the idea. Even the Spielberg could imagine that movie was taken. It was a first inspiration for me. And most of the Kalam's classmates are all my teachers in the high school. So he is from the Rameswaram. That way I get acquainted. I heard his name. I know all his family and everything. But 1970, when I went for the interview after MTech from IIT Kharagpur in aerospace engineering, I attended the interview and he was one of the interview board members who selected me. Okay, I don't know what is his standard. He selected me. So I am a standard person, I think, at the time, and I also joined him as a junior engineer in Vikram Sarabhai Space Center. At the time, our Susumundan sir and everybody was also working there. They are all seniors. Okay, with a small introduction, I will start. Because time given is very small. I'll upload my PowerPoint. One of the important event in this meeting, sir. Kindly check up whether I have done correctly. Sir, my PowerPoint is visible, sir?
Yes, it is visible.
PowerPoint is visible?
Yes, visible. Visible, sir.
Visible.
Visible. Just yes, I kindly read, somebody read so that I can confirm I am going to the slide correctly.
90வது சுற்று வட்டப்பாதை.
Orbital. So he used to tell I am in the 19th orbit, 83 orbit, like that he used to tell. And it is his 90th orbit. If we are live, it is 90 years. And actually, the same day on 2003, in 70 years, China first largely first man, Chinese man orbited the Earth after Yuri Gagarin and Al Shepard from US. And third country which launched their own rocket and orbit the Earth is a Chinese man. So he has exactly the same birthday the years are running. That's all right. Okay. So guiding space. So I am a DMIT with a particular. I am a BSc Physics from National College Trichy. MIT from Back, same because I was asked to study what he has studied. Then when I asked the teacher, wow, how to design a rocket, he told you must study as Abdullah studied. Kalam was known as Abdullah only, not Abdul Kalam. So what Abdullah studied, he studied BSc Physics in Trichy and MIT in Chennai. So I did the both. I am BSc Physics from Trichy and MIT from back, and MTech from IIT Kharagpur, 1978 batch. So Kalam, he has a lot of dimension. Kalam Ethanai Kalabadi. He has starting from student to a people's president. He is a powerful president. But if I understand, I have read a lot about him. I understand he is a saint, basic in all, in every day. He is a saint. His mentality is going to philosophical, and he is a saint. He is a saint scientist, as I.G. Kudaral used to tell. He has a lot of hardship. So starting from his Air Force dream and his president Ayapura, he introduced. He could he met lot of failures than success in his life. That's what I have seen in his biography. Air Force in ADE, he was designing he designed. He was kind of involved in four, one sounding rocket, one satellite land vehicle, missile, five missiles, and a BrahMos hypersonic missile. These are his involvement in various areas, like a various projects. Sounding rocket, he was a small engineer. Just now come from NASA. NASA first sounding rocket, he was only just 2 weeks from NASA, he has come back with the payload. And Vikram Sarabhai used to tell him he's a payload boy, called Kalam as a payload boy. So his experience started with the sounding rocket, where only he stabilized his technology, according to me. Law of the timer and range safety, all the things were completely learned by him at those time only. Whatever he implemented, then it give you after some 10 years only, he was given the SLV in charge as a project manager first, after that project director. Then 82 he left to DRDO for various reasons. And at that time, President Venkatraman also one of the instrumental to get him to DRDO. And he also want to go out from ISRO for certain reasons. And 2011, he made a JV for BrahMos. That is Dr. Sivada, along with Dr. Sivada Pillai, a company formation, a JV, which was very different at that time. And he said BrahMos, there's a hypersonic missile, cruise missile. Even US Tomahawk, also not much performance better than the BrahMos. So I have to tell, one of the first encounter with him, he gave an analysis to us. You can see SLV is different than other things like a PSLV, GSLV you'll be seeing. The tower will be different, the vehicle will be different. They will be standing apart. But SLV only the launcher is holding the vehicle very close to it. Only SLV only happened like that. He called me and gave me analysis, asked me to analyze this, for a vibration analysis, the dynamic response analysis actually, to how the leaving vehicle is, how it will collide or interact with the due to its flexibility of the larger structure. Because the SLV is resting on the pin here. The background, there is a pin is there. Due to the self-weight, it is sitting on the base and there is a pin is inside. So it will be holding the large weight. He gave me to analyze the vibration, do a response analysis and tell me when the leaving vehicle, it has to cross the length of that structure around some 20 meters. In this gap, some 4 seconds only. The 4 seconds, whether it will interact or collide with each other. It was a work given to me. I did doing the APM analysis. I carry over 1 month, 130 months. Even I stayed very long in the evening. Some other time he'll be waiting in the jeep downside and pick up, and he was inside. And we used to even he convert jeep anything as his room. That's all. Every Tuesday there will be a project committee meeting will be there. And at 5 o'clock, everybody will leave for 7 o'clock. At that time, only one car was given, one jeep. Sometimes all will punch into the jeep, and he will continue the PRM in the jeep itself. Still, he is going to city. So, like is his nature. He is always in the work colleague, and he will always the work only. So he was discussing, and he find out he made me to run some 30 to 35 runs. and I went and showed him the result. He gone through the result and picked up some of the outputs and everything. And finally decide if the vehicle leaves some 0.4 or 0.5 seconds earlier, then there will not be collision between the launcher, SLV launcher and the vehicle. It was a great one how to do that, how to 0.4 seconds. Then he himself gave a solution. He cut the pin. It was 50 mm pin. He was cut it to some 40 mm, some 10 mm he reduced. So vehicle was released from the launcher. So very simple and very indigenous and very simple practical solution. Not a big solution. This very practically he gave it. That was my first experience with the Kalam. And in DRDO, it is 1980s, 82. The Agni launch, it is Agni Parichay only. Agni is Agni Parichay for Kalam. So Agni gave a lot of problems. The design itself, 82, we want to run a hypersonic wind tunnel to test the model of the Agni. And nobody, and he was in charge for SSM, SIM, IRBM, ICBM, all these intercontinental ballistic missiles. Something we want to test. It will go at the speed of 5.5 Mach number, around some 67 kilometers per hour. It will take hypersonic speed. Agni. So we want to test this in a hypersonic wind tunnel. So subsonic, supersonic was available, but hypersonic was not available in India. And the US is watching our progress in the intercontinental ballistic missile, which is threat to them. So India is strengthening its missile arm. So somehow everybody is rejected. All the big countries rejected. We approached. He approached every big country. They rejected. Finally, West Germany, Stuttgart. Yeah, there was a hypersonic tunnel, which agreed to test our missile somehow. So a 7-member team from DRDO arrived Delhi to go for a Stuttgart. The last movement. At the time, it is Ronald Reagan was a president of US. US is watching. US is not happy about our intercontinental ballistic missile development. Even though the initial stages, the US gave all training, everything. And they gave the scout, all the SLV, they supported, etc. But we are developing ICBM. When it comes to the case of ICBM or IRBM, they are not happy with India. So they put a MTCR, Missile Technology and Control Regime rule. According to the rule, we cannot launch the Agni. Where Agni is more than their standard. Whatever standard told, it exceeds that. It was going. So Agni, it's a 100 hypersonic tunnel. So MTR missile is selling only 500 kg payload for 300 kilometers. But ours is 1,000 kg and 5,000 kilometers. We want to do the right in here. Agni. So what to do? There was the individuality of a Kalam, we can see that. It was a hardware. A wind tunnel testing is a hardware model testing. But you switch it on to the software testing. Suddenly, he was looking at CFD professor IASC, there's Dr. Deshpande. He was working on a new area that is called computational fluid dynamics. Now, even a BE of aeronautics student is doing. So, computational fluid dynamics, Kalam went and talked with them. And instead of wind tunnel, we will do a computational fluid dynamics and launch a vehicle. And we'll come back to flight test, that standard. What is the standard you have to follow? We will do a CFD of the vehicle which you have already flight. Had done a flight and the flight data is available. Do a theoretical CFD, compare with that, and do the theoretical for the Agni and launch. So this was his problem solving. Immediately he went to another domain. He never involved himself in the problem. He looked above the problem. That's the reason why he want to fly above and see all the things. Even when he was young, he want to become a pilot. Before that, he want to become a coconut tree climber. So he thought when he was young, a coconut, if you go up the coconut, you can see all the things clear. So going up is aim. Either it is a coconut tree or the aircraft. So go up and take a eagle view of the problem. That's what that he has done that. Professor Deshpande, father of CFD, right? He did IIC, CFD requires a supercomputer, but it requires a supercomputer. The next problem comes in form of computer, and there was no supercomputer at that time in India. Again, we go to US, right? A CFD DRDL group formed, require a high-speed computer, and there are some methodology also designed. And he went to US to get a supercomputer. That Microsoft chief or IBM chief met him and very happy to meet, and they gave him a good breakfast and gave him a good lunch and told Kalam, I am ready to give you a good dinner, but not the supercomputer. You can go back. So he come empty and developed the supercomputer. So this indigenization comes from insult. Or wherever he insulted, so he converted into a innovation and indigenization. So he developed a Param computer and solved that, and he launched. The day of launch has come. You can see that in the picture, Dr. Arunachalam, V.S. Arunachalam, who was a guru of Kalam, who recruited DRDO. Actually, Kalam followed his steps. He also became DRDO and he also became scientific advisor. And he became president, of course. V.S. Arunachalam went abroad for some other thing. So he met him, and there was a call from him early in the morning. There was a ITR, integrated testing rate in Sandipur at Orissa. Early morning. There is around some 3 o'clock. A call from Dr. V.S. Arunachalam. Agni is standing on the pad, Agni on the launch pad. 4 o'clock, before 5 o'clock, we have to launch. Otherwise, after 5 o'clock, there is a cyclone is hitting. So there is a type condition, and V.S. Arunachalam called in the phone and conveyed that Mr. Cheshan, T.N. Cheshan, Cabinet Secretary to the Prime Minister, the device want to talk to Kalam. Even in SLV, Cheshan and everybody has worked together. Everybody knows him. He is a Madurai collector once. When most of our engineering students then joined under him. When he was working in admin controller in ISRO. But so Cheshan is on the phone. Directly come to the point. Mr. Kalam, where are we in Agni? Right, he's asking that Bush is the president. He is giving the pressure to Rajiv Gandhi. Rajiv Gandhi is in turn asking Kalam, and Cheshan is asking Arunachalam. Arunachalam is implying Kalam. Like that, they are way. And America is not happy about our development of the Agni. So it can be delayed. Where are we in Agni? Kalam very courageously replied, it is not wait and watch situation. It is an act and achieve situation. I am going to act. Agni is no point of return. So he launched it before 5 o'clock, and before cyclone also came, all of them wind up and went up. So this was his courageous thing when we applied in the Kalam. So that's what it told achievement Madamayana. That's what he proved. The word he never is the courageous. He gave his courage. Right, like that only. There was a element called beryllium. It was necessary for the development of satellite and path. And US was supplying. Somehow, when we are requiring, we will use import from US. But suddenly US stopped giving that. Then where the US is getting the raw material, that is from Japan. When we contacted Japan, the Japan is telling they are giving the raw material from India only. So the loop is to India, India to Japan, Japan to US, and US to India again. So he cut short at that beryllium. This one he prepared in India itself. Like that, LCA DISAS was under development. They will develop a control software. They will give the computer and the system. They will develop the software. And Lockheed Martin is the biggest company in USA. They worked in there. So we are given, contract was given, but the development is going on. Our Ukraine atomic bomb, we have done that exploration. So they were not happy. All the engineers were sent back, and they took the computer itself and went along with the software. Same next day, there was all the control and computer science system software, flight dynamics people of India was called for a meeting, and Kalam was heading, and we developed a local control software, autopilot control software. So like this, even GPS, coming to GPS, on Kargil war, and we need a maps of Kargil, the satellite map. We asked to US didn't give. So we developed our own GPS IRNSS, which is now called Civic. So this kind of utilization is the basic strength of Dr. Kalam, which he learned from his young age. When his father was building his boat, he was using certain material with corrosive resistance and hand resistance. That's why he always in the composite. He like composite system. And one day night, when Vajpayee became a prime minister, he asked Dr. Kalam whether he can join with us as a minister in the cabinet. And Kalam was thinking of, there are two jobs are there. Still I couldn't send Agni, and there is a atomic bomb explosion is there, so I cannot join your cabinet. Very well. Who will tell like that? He refused because that much is sincere. And when again Vajpayee came as a prime minister, he called him as a president. This time, don't say no. Right. So that is what his involvement and declaration which I enjoyed and we used to follow. Right. Let us say there was a Mars climate. Let us come to that. Time is running out. Mars climate orbiter. The Mars climate orbiter was launched from US to analyze the atmospheric conditions of the Mars, weather conditions of the Mars. It's a polar orbiter mission, part of that. Yes, it was launched. This is a satellite. You can see with the solar array and everything, very beautifully built, very beautifully designed, and it was launched. Right. What happened? Launched along with the Mars Polar and Lockheed Martin again. Yeah, Lockheed Martin was the designer of the software. One part developed by Lockheed Martin, one part developed by NASA. Right, very good. It is a combined effort, we'll operate. And it's a launch date. It was launched on 11/9/98, and it will take 9 months to reach Mars because of our optimized trajectory. Yes, after 9 months it reached, and the $327.6 million USD is the cost of the project. So that much cost worth the spacecraft traveling to Mars. What happened? On September 23rd, 99, the spacecraft approached the Mars and it has to orbit the Mars now. And it will go beyond the other side of the Mars, there will be signal cut off. Actually, signal come from Mars to Earth, it will take at least 15 minutes. Right, not like Moon 1 second. So after that 45 minutes, everybody will hold their temper. Even Mangalyaan also, there was a tense moment. And the spacecraft going other side of the Mars and it must come back. Still we see the spacecraft coming by from the shadow, then it is a problem. It is right behind Mars and it didn't come back at all. It went 49 seconds, earlier it went. See, the second is a very large time in space. 1 second light will reach the moon from here. So 49 seconds, earlier the spacecraft ended. I don't know, it didn't come back, other side, everybody was waiting, it is not lost. The spacecraft is lost. There is no radio contact and communication contact, that everything is not reestablished. So a Mars rover is lost. What is the reason? This is the way it goes to land. It must have landed, but they release a report. They release a report. What is this one? The trajectory control, one part was done by Lockheed Martin, as I told. Another part was by NASA. But when they exchange the software, both the parts, they forget one thing. What is that thing is? That measurement of wind. One is in SI unit, another is in international. One is in kg, another is in pound. One is in centimeter. So they are in feet, inches, another is in meter. So in 99, the 120 Mars Jupiter report, because of the units are not same. So what happens if the units are not same in space? Supposed to be a Mars, cells are supposed to be here. It has already come to 57 kilometers close to the Mars. According to the planned trajectory, it is 226 kilometers. Because the same units are not followed both the sides, this error has happened. So spacecraft is here instead of here. So it starts descending and dashed against Mars and blundered into the Mars and failed. So 326 million USD dollar has come. What is that? That is because of English to metric measurement when exchanging the vital data between these two organizations. Yes, somebody asked. So 1 NB is not 1 Newton, it is 4.45 Newton. Right? So this kind of things happen, and 1% units are important. So never we can't have a single standard across the world. Somebody in the failure analysis committee, he used the word standard. Why we cannot use a single standard across the world? When I think of the standard, this incident only come to my mind. Right? Once a unit, it failed 120 million US lost. So that is the important of the standard. Whenever we tested, we got lot of environment levels. We use a satellite and lot of other than the right side satellites also will be there. We have launched 104 satellite in one launch in PSLV. So how they are this one? But they are supposed to be a frequency. Even though a rocket seems to be a rigid one, it will bend like this. First mode, second mode, third mode, all vibrational bending frequencies. And there will be equipment, instrument unit and at those places, which will sense a long sensor due to vibration. So how to avoid that? So we have some levels. This is a bending mode of Saturn Apollo vehicle. You can see that. Yeah, first mode, lot of displacement in the end. So which will affect this displacement also will go along with the rigid body frequency, rigid body mode of the vehicle. Rigid body mode plus bending mode all will add to the displacement at the very essential point like the instruments, right? Or the red zero location or anything. So that we have set up a standard, frequencies must be like that. So the vehicle frequency, fundamental frequency must be down because too much down it will interact with the control frequency. And liquid permanent have slashing frequency. So all these frequencies should not couple with each other, especially bending frequency coupled with the control frequency, it will break the vehicle into a spin. So we have a standard of below 30 hertz and loads also. We divide by 7G compression and 3 point because the thrust is more. So it is a compression than the lift. So for 3.5G tension, lateral G also there. Right, ultimate load factor is 1.25. That's all our standard for that. Right? The stiffness wise, the satellite launch must have a longitudinal frequency more than 90 hertz and 45 hertz in the lateral direction. So these are our standards, and we have test velocity, colligation model, and acceptance model will be there. Is a vibration, shock, thermal vacuum, thermal planning, and emissions. All these are things we have to. These are the kind of environment a satellite subject. It is we see that frequency ranges and coordination actual 10.5 mm double amplitude, 23 mm is acceptance and level. So axis, longitudinal axis and lateral axis, we have given a mid standard of sweep rate to design a satellite. It is for frequency. It is for a random vibration frequency. You can see that frequency level from 0 to 2000 hertz in the GRMS. It will come around 4.47 the acceptance. You can see that shock spectrum because the satellite is separation is more important. Stage 1 stage separation, heat shield separation, stop on separation, satellite separation. So all the things are there. Each separation there will be a shock in the heat shield. It has to come out. Recent one there will be like a shock will pulse a pyro bolt will be there. It will explode and the heat shield will come out. It will split into both longitudinally and laterally. So this kind of shock environment has to be also tested for a satellite for it must resistant. Right? It is a emission test. You can see that it needs band wise. And so the design loads, frequency, mechanical interface, surface protection, qualification list. These are the standards we are following in the satellite. Okay. So in the thermal environment. So even for a small SSLV which is going to come, you are seeing the range, the same thing. We are even it is a small vehicle also. SSLV is going down. It is going to launch from Kulasekarapatam near Tirunelveli, and even the first launch is not yet done. And already there are complete vehicle is payload is booked by 2 agencies. Right. So the environmental levels are more important for the satellite for the performance. Otherwise, the wrong performance will be coming, and will develop for acoustic also frequency ranges. So these are the environmental levels. Okay. So with it, I will close it. Any questions I can answer. I think I have 45 minutes. I think. Any question about Kalam or anything also welcome.
Thank you, ELANGOVAN.
Dr. ELANGOVAN, nowadays the standards are getting revised in terms of if you see MLT, mass, length, time, all the measurements are based on earth constants.
Okay.
Earth constant. So earth sphere, diameter, circumference, we used to tell the length, but that is changing. Similarly, mass is depending upon your unit of the size and other things.
Yeah. Face was
Yeah.
Face. Face was. I want to see you after a long time. Okay, sir.
The length is like that. There is a variation. Time is second. You know that time is based on the earth rotation. That has been changed to the atomic clock to the accuracy of 10 power 23.
Right.
So earth, so far earth phenomena were taken as the standards earlier, either M, L, T. Now that is getting revised. In terms of length, mass, earlier used to be the pound, then gram, kg, per Newton. If a blank's constant,
Blank mass.
Blank
Blank mass. Yeah, I heard about it.
blank constant.
Blank constant.
That is blank constant. That means they measure the mass in terms of the electric magnetic force. How accurately give you a force, that is taken with an accuracy of 10 power 15. So kg is going to be no longer a mass unit, weight unit later. It is going to be a blank constant. Is
Blank
going
constant
to
in the future. But now the large vehicles are using the mass only, right? Propellant mass, petrol mass, all are in kg. In tons.
No, even Newtons are not being taught in some colleges. So what I'm trying to say is standards are getting revised and soon international level without the reference of earth parameters, whether gravity or length or the time of rotation, it is going to change. The time is I'm expecting within a span of 2025, these standards may change to some extent.
Thank you, sir.
This is what the information. This is what information I.
Yeah, right. That might be the quantum. Black constant consider the quantum mechanics. I think, yes, might be the future.
Yeah.
But how anyway, you have to calculate inertial force with the M only.
Yeah, inertial force.
Important inertial force is the M.
About audience, anything about Kalam's silent characters? Silent character, anybody is willing? We people have worked with the Kalam for quite a long time.
Yeah, so students are there. What kind of characters?
What I used to say is, when we work in a project or in an experiment, unless that task is completed, you will not go home. Try to complete the task, achieve some goal. If it is in a shaker table, you do the shaker and find the resonance and the frequency response out. Everything you take measurements, then only you can test it. No question of leaving it today and tomorrow come back and this. This is the special property, character traits I observed from Kalam.
What I heard is there was he was working with Dr. Satya and Madhav Nair. Those are the two people who joined him as an assistant when he was in the sounding rocket period. One of his Murthy was a boss. When he came, the midnight 3 o'clock, these people are working for a sounding rocket project for the experiment, for the payload has to be launched. And they were in a very bad situation. Their kind of face, eye, and now 3 நாளா சாப்பிடல, குடிக்கல, rest change பண்ணல, எல்லாரும் including Kalam. He fired and asked the people to go back to your room and come back tomorrow. The team went and were returned by within 2 hours. They come back and resume the work. That is also told. Another this one GS Murthy told me that Satya told me that one day his father, Kalam's father, came in search of to Tumba because telling that 1 year, 6 months there is no communication. 1 year there is no letter, there is no money, nothing. So I came to Tumba to see my son. And again, GS Murthy was the boss at that time. Called Kalam, go to take him to Trivandrum bus stand, go to Nargoil, then go to Madurai, and took a train to Rameswaram. Be there for 4 days. Your leave is given, you go and come back. Exactly 4 hours, Kalam has come back after leaving in the Trivandrum bus stand his father and continued the work. So that is the way he used to work. That's what I used to do. I used to care. This is why Satya has told me. And like that, Savdana Pillai, a lot of people. Those who work with him is a devotion. And there are some 2 or 3 people who worked along his career. One is at Aram for the initial stages, and another one is Sandless base. He became the project, he is the project director SLV after Kalam. Third SLV, Kalam was not the project director. Sandless was the project director. Fourth SLV, Kalam didn't come for the launching also. Right, at that time. So like that, he has done a lot of things, very simplification and talking to the people and saving the people. All the leadership qualities you can see in him. Anybody else also can share their view.
Self-reliance.
Yeah.
Self-reliance is the main motto.
Yeah, I explained 2 things, self-reliance. The basic.
Okay. Thank you, Dr. Elangovan.
Yeah, no problem, sir. Thank you, sir. Thank you for the opportunity.
Secretary.
Narayan
Narayan.
What are thanks?
Vote of thanks.
Okay, sir. Once again, good evening to everyone, sir. And today's Dr. APJ Abdul Kalam sir's birthday. Professor ELANGOVAN RAJAGOPALAN sir, he has shared what are the contribution along with the Dr. APJ Abdul Kalam sir he has given. And our Dr. Shri also just shared his view of the Dr. APJ Abdul Kalam sir's motto and his working conditions, all these things, sir. On behalf of the Madurai Local Center, we thank our chief guest, Professor ELANGOVAN RAJAGOPALAN sir, and our council member Goswami sir, our chairman Rajagopal sir, and chairman-elect Dr. Shri sir, and all the members, cooperative members, and the members who has attended this meeting. On behalf of the Madurai Local Center, as a secretary, I thank to you, one and all who has participated on this meeting, sir. Thank you very much, sir. Thank you, one and all. Thank you, sir.
Thank you, sir.
Thank you,
Thank you, Dr. Shri.
Thank you. Thank you, Elangovan.
You found the opportunity to talk to here and to meet all the seniors. Thank you, sir. We'll
Thank
meet
you.
in person sometime.
Thank you, sir. Thank you, sir.
Thank you.
Presentation.
Yeah, I have to go to another webinar.
Thank you, everybody.
Presentation was very colorful
Thank
and
you.
nice, sir.
Now we are closing the meeting. Narayan Swami, we can close it.
Close it.
Elangovan, sir,
Yeah,
please send the PPT to us.
PPT. Okay, I'll send it. This one I send it. No copyright issue. I will send it. Definitely.
Thank you. Tamil Nadu Center.
Thank you. Thank you, Elangovan.
Thank you, sir. Thank you for the
Thank you.
opportunity, sir. Thank you, sir.
Thank you.
I'll go for another webinar.
Thank you. Thank you.